So now we will be looking at arithmetic sequences. And so arithmetic sequences, they're defined as like the sequences that have a common difference. So for term 1, the first term we call it A, and so that could be I'll just give you an example of an arithmetic sequence. 2, 5, 8, 11, 14, 17. So it goes up by 3 every time, and it's a constant difference. So how can we generalize this formula? Well, because with every increase in the number of terms that it is, you're adding 3, right? For every term you go up, you add 3. So its rate of change is 3. So its gradient is 3. So it'll be 3n, where n is like the number in the sequence that a term is. And then what we do is we would substitute in that first one plus c is 2. And then so 3 times 1, because that's the first term, plus c, equals 2. So c equals minus 1. So this would be 3n minus 1, would be tn, although Cambridge does expect you to do un. But how would we derive the formula that we have? Well, you notice that it's going up by 3 every time, and if we call 2 a for first term, then the second term will be a plus d, then this one will just be a plus 2d, right? And then a plus 3d, and hopefully you're seeing a bit of a pattern. D stands for common difference. So you're adding d every time. You start adding d from number 2 onwards. So that's actually a plus n minus 1d. And this is a formula that you get on the formula book. And by the way, it'll look a bit like this. Arithmetic sequences are straight lines on graphs. So obviously a very free question would be like, they give you the first term and they give you the difference, and it asks you for like the 9th term or something. You know, very easy stuff. The next thing I'll talk about is like the sum of an arithmetic series. And so we'll do a bit of history. There's a famous mathematician called Gauss, and his teacher told him to add up all the numbers from 1 to 100, thinking it would take him a while, but he found a creative way. And if I just put in a few more, we'll start to see something. He realised you could just go 101, because 100 plus 1 is 101. Then 2 plus 99 is also 101. 3 plus 98 is also 101. And all the way up to 50 and 51, which is also 101. So he realised you could just go the first term plus the last term and multiply it by the number of terms divided by 2. So that is one formula we have for the sum of an arithmetic series. But what if we don't know the last term? Well, we can always know the last term because of this general formula. We don't need that additional variable because it's just another a plus n minus 1d. So all we would need to know is just the number of terms in the series. So 2a plus n minus 1d. 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 2a plus n minus 1 and generally the n over 2 is at the front. Sometimes if it does give you the last term, you may have to figure out the number of terms in it based on the common difference and the first term, so you can find the sum. But that's not that hard. This topic isn't particularly difficult. You just need to know how to do algebra. The main thing is you just want to try and substitute everything you know, and you'll find that, and sometimes it can be helpful to rearrange things to get A in terms of D or D in terms of A, then substitute that in, and then substitute whatever you find D or A to be into the other one to find out the other one, if that makes sense. We do that a lot with simultaneous equations, so I don't think you'll have much of a problem with this. But perhaps sometimes it's like it tells you that the sum of n is something like 12n minus 2n squared. And you need to find the first term and the common difference. Well, if you say you double both sides, 24n minus 4n squared, then if we were to expand this, we would get 2an plus n squared minus n d. That's equal to 24n minus 4n squared. And then if we expand that again, the dn squared minus dn is 24n minus 4n squared. So now we get 2a minus d n plus dn squared equals 24n minus 4n squared. And that would tell us that, well, d equals minus 4 and 2a minus d equals 24. So then that would make it 2a plus 4 equals 24, 2a equals 20, and a equals 10. And if it isn't obvious already, d would be the second term minus the first term. But that's just another thing you could write in working to make sure you get that. I mean, look, a lot of these things, that's probably one of the few difficult type stuff when you have to actually do a fair bit of algebra. Honestly, I think all the other question types, unless it gets combined with geometric, which it can do, which we will cover in a later video, it's fairly logical. You just got to use your brain and do algebra. Perhaps the other thing that I would suggest to you is be pedantic with your working, be clear why you're using certain numbers and your understanding of numbers and the calculations you're doing to obtain things like the common difference or the first term or the nth term or the last term or the sum. And remember, write your formula, then you do your substitution. But yeah, other than that, seriously, just use those formulas. They are in the formula book, which makes it easier. And just be prepared to do some algebra.